Varying quantities have values that can be represented by a variable. For example, let h represent Kristen's vertical height above the ground in feet as she rides a Ferris wheel. When h equals 19, Kristen is 19 feet above the ground. When h equals 30, Kristen is 30 feet above the ground. For any varying quantity, we can also imagine a new quantity that represents changes in the original quantity's value. When Kristen's height goes from 19 feet above the ground to 30 feet above the ground, her vertical distance above the ground changes by 11 feet. We can represent this by saying delta h equals 11. Therefore, there is a difference in meaning between h equals 11 and delta h equals 11. If h equals 11, it means that Kristen is 11 feet above the ground. If delta h equals 11, it means that Kristen's height above the ground changed by 11 feet. Changes in a quantity's value can be represented algebraically as the difference between some final value and some initial value. Let's see how this is developed. At some moment, Kristen was h sub I feet above the ground. Then the Ferris wheel rotated and she was later h sub f feet above the ground. We can say the following. The initial height plus the change in height is equal to the final height. So h sub I plus delta h equals h sub f. We can rewrite this relationship as follows. The change in height is equal to the final height minus the initial height. So delta h equals h sub f minus h sub I. When describing changes, positive numbers indicate that the value of the original quantity increased, and negative numbers indicate that the value of the original quantity decreased. For example, as Kristen continued to ride the Ferris wheel, at one moment she is 28 feet above the ground, and later she is 12 feet above the ground. Then, delta h equals h sub f minus h sub I, so delta h equals 12 minus 28, which is equal to negative 16. Kristen's height above the ground decreased by 16 feet, so we use negative 16 to represent the change in h's value.